Welcome back. We're going to be going over the next couple questions here on our practice test again. First one here is number 14. Which of the following circuits can be used to test whether or not a wire of laminated heating element is cut internally? So what they're really asking is inside this wire, it's laminated, meaning it's got a coating. Whether it's an orange coating, black coating, it's got some type of coating on it. They want to know, what can we do to find out without cutting the wire, or which one of these would test to see if it somewhere has been broken? Well, that means we're going to be testing the current. So what it really comes down to is which one of these tests the current. Well, we know that D is not it because it's testing the voltage. That's a voltmeter tester. So then it says, are we going to be testing the current? And how do we hook current up? Do we hook it up in parallel, or do we hook it up in series? Well, current, we have to measure the multimeter in series. So C is no longer an option there as well. We have to have the current go through it. The last one then here is A and B. Well, for there to be a current going through it, there has to be a battery or a voltage supply of some sort, an EMF. So A does not have that, so it has to be B. Okay, it says in the circuit below, the ammeter shows that there is a current. However, the bulb does not light because, well, what we've got here is this part here, and we haven't talked a whole lot about this. This is a potentiometer, and that's like a dimmer switch. And what that does is it either cranks up the resistance or turns down the resistance. When you turn the resistance down, you get a lot of current, which means the light bulb gets really bright. When you turn it the other way, the resistance is highly increased. Well, current and resistance are opposites of each other, so that means there's going to be very little current. So which one of these cases do you think would make a situation when there wouldn't be enough current for the light bulb to light up? Well, it's this one right here. The variable resistance has a large value, all right, and that's what we're talking about. Okay, in this case here, in the circuit below, shown below, which bulb, when burned out, will cause all the other bulbs to stop glowing? Well, we know that that's only going to happen in a series circuit, because in a series, the current will be stopped if one of the light bulbs goes out, because it only has one choice. So which one of these are hooked up in series? If this light bulb goes out, it doesn't change. It only makes this one go out because that circuit is broken. These would still all stay on. The only one that is entirely hooked up in series is A. If we break this, no current gets to D, B, C, E, or F. So A is the one that's hooked up in series. In a series circuit, each circuit element has the same blank. Well, one of our concepts that we talk about when we do our parallel and series circuits, and we have to write our V equals I times R, and we make the whole table out, is that we know in a series circuit there's only one path. So that means that the current has to be the same. So in this case, in a series circuit, it's the current that's always going to be the same because there's just one path for the current to flow. In 18, if a resistor is added to a series circuit, what does this do to the equivalent resistance? Well, we know that in a series circuit, our equation is we simply can take our resistors and add them. So if I add another resistor, if I add, let's say, an R4 to this, well, then the total resistance is going to be higher than what it originally would. So if a resistor is added to a series circuit, the equivalent resistance or the total resistance will increase. It will increase. Okay, this one says if a resistor is added to a parallel circuit, what happens to the equivalent resistance? Well, in this case, I've made a parallel circuit over here, and I've said both of these resistors are 12 ohm. One of the shortcuts, if you remember back, I told you that if there was a certain number of resistors, you could go through our steps of adding up the inverses of the resistors and then take the inverse of the answer. Or we can simply, if they're both the same, we can divide them by 2 and say that in this case, RT equals 6 ohms. Well, what happens then if I add a third 12 ohm resistor? Okay, I'm doing this. I'm adding another resistor to this parallel circuit. Well, now I have all three of them are 12, so I'm going to divide by 3. Well, what happens? RT becomes 4 ohms. So what happens to the overall equivalent resistance? It's going to decrease. Okay, we've addressed this one several times. The number of current paths in a series circuit is going to be just one. There's just one path, and that's why they all get the same current. There's like a river that didn't have any branches. It would have the same current at the beginning of the river as it does at the end of the river. So it's just one path. Okay, in this situation here, what they're really wanting us to do is they're asking us, or they're telling us we have a 10 ohm and a 30 ohm resistor that's connected up in series, as I have here in my first example. Then they tell us, and they've got a 100-volt battery. Over here we've got a 100-volt battery, and we've got a 10 ohm and a 30 ohm resistor hooked up in parallel. They want us to find out the ratio of the voltage drop across the 10 ohm resistor in the series combination to that of the 10 ohm resistor connected in parallel. So they want us to do a ratio. What is the 10 ohm? What is the voltage, all right, across the 10 ohm in series over what is the voltage of the 10 ohm in parallel? Well, I've kind of did some of this work for us. In a series, I found the total resistance to be 40 ohms. I then solved for the current flowing through this series circuit, and it was 2.5 amps. So the voltage drop across this 10 ohm resistor was going to be the current times the resistance, or 2.5 times 10. So the voltage drop across the 10 ohm resistor in series is 25 volts. Again, all they're asking for is a ratio. We got to make a fraction. The other one is much simpler because they tell us it's in parallel. Well, what do I know about the voltage drop across resistors in parallel? Because it's in parallel, each of these are going to get 100 volts. So it's 100 volts is what the voltage drop is in the parallel. Well, what is 25 over 100? It's going to be 1/4. Okay, I've went ahead and taken some time to save time, made a drawing here. It says a 4 ohm resistor, an 8 ohm resistor, and a 10 ohm resistor are connected in series across an 11 volt battery. The total voltage drop across the 4 ohm and 8 ohm resistors is, well, what I've got to do is I've got to find out how much voltage is there going across the 4 and the 8, and find out how much is left then once it gets to the 10 ohm resistor. To do that, I'm going to go through my steps. I'm going to find my total resistance. It's a series circuit, so I'm going to add them. 4, 8, and 10 gives me 22 ohms. My voltage is 11 volts, so the current has to be 1/2 of an amp. Well, there's a couple things I know. This is going to stay 4 ohms, this is going to stay 8 ohms, and this is going to stay 10 ohms. Each of these are going to get 0.5 amps because it's in a series circuit. So what's half of 4? 2 volts. What's half of 8? 4 volts. So how many volts are being used across the 4 and the 8? 6 volts are being used. All right. So what's the total voltage drop across the 4 and 8 ohm resistors? 6 volts. Okay, in this problem here, there are 4 coils of wire being used as magnets. They all have the same size and are made up of same material but have a different number of loops. Which coil will produce a magnetic field with the maximum strength when the amount of current passes through, with the same amount of current passing through all loops? Well, you're going to have the same current, but there's a whole reason we make these solenoids. We're talking about loops, so we're talking about solenoids here. Well, why do you think some motors have lots of wire, and then more expensive motors have even more wire looped around them? Or why do you think stronger motors have even more wire? Why are they bigger? Well, it's because they can get more wire, or they can get more loops. So it's going to be the one that has the most loops. The more loop, the more field, the more magnetic field you're going to get. Hey, this has been great. We only got through question 23, but I think we've gotten a lot done. I'll see you on the flip side.